Article 250.104c of the National Electrical Code addresses the bonding of service equipment, specifically concerning conduits. This section states that in the case of conduits or raceways installed as an integral part of equipment, the metal conduit or raceway shall be bonded to the equipment grounding conductor, terminal, or busbar. Considering this regulation, it is important to clarify how it applies to installations involving pad-mounted transformers and underground primary systems. The requirement outlined in Article 250.104c pertains to raceways that are installed as an integral part of service equipment. This definition includes pad-mounted transformers. The code mandates that the bonding conductor must create a connection between the conduit or raceway and the equipment grounding conductor, terminal, or busbar located inside the transformer. To clarify, the question of where to terminate the bonding conductors within a pad-mounted transformer is important. Pad-mounted transformers are generally equipped with a grounding stud or a terminal strip specifically designated for the purpose of connecting grounding conductors. It is to this designated grounding point that the bonding conductor should be connected. The relevant code references the National Electrical Code, specifically the 2020 edition, and more precisely Article 250.104c. The core purpose of a bonding conductor is to establish a continuous electrical pathway that allows fault currents to return to their source. This pathway is designed to protect both the conduit and the equipment from sustaining damage. In an electrical system, a fault current is an abnormal electric current flowing due to an insulation failure or short circuit. Without proper bonding, these fault currents could energize metallic parts of the equipment, creating a hazardous situation. The bonding conductor provides a low impedance path that allows the fault current to quickly flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. This rapid response minimizes the risk of electrical shock or fire. When installing an underground primary system, it is essential to ensure that all metallic components, including conduits and transformer enclosures, are properly bonded together and connected to a grounding electrode system. This system typically consists of ground rods, ground rings, or other approved grounding electrodes that are buried in the earth. The grounding electrode system provides a connection to the earth, which serves as a reference point for electrical potential. This helps to stabilize the voltage and further reduce the risk of electrical shock. The size of the bonding conductor is determined by NEC Table 250.102 cone, based on the size of the service entrance conductors. The bonding conductor should be made of copper or other approved material and must be installed in a manner that protects it from physical damage. When installing the bonding conductor, it is important to avoid sharp bends or kinks, as these can increase the impedance of the conductor and reduce its effectiveness. The conductor should be installed in a straight line whenever possible and should be securely fastened to the conduit and the grounding point in the transformer. The connections should be made using approved connectors and should be tightened to the manufacturer's specifications. It is also important to ensure that the bonding conductor is accessible for inspection and maintenance. The conductor should be labeled to indicate its purpose, and a record of the installation should be kept for future reference. In addition to the requirements of the NEC, some local jurisdictions may have their own specific rules and regulations regarding bonding and grounding. It is always a good idea to check with the local electrical inspector before starting any electrical work to ensure that you are in compliance with all applicable codes. The purpose of bonding and grounding is not only to protect people and property from electrical hazards, but also to ensure the reliable operation of electrical equipment. A properly bonded and grounded system will minimize electrical noise and interference, which can improve the performance of sensitive electronic devices. It will also help to prevent voltage fluctuations and other power quality problems that can damage equipment. When designing an electrical system, it is important to consider the specific requirements of the equipment being served. Some equipment may require special bonding or grounding arrangements in order to operate safely and reliably. For example, sensitive electronic equipment may require isolated grounding, which involves separating the equipment grounding conductor from the building grounding system. This can help to reduce electrical noise and interference. In other cases, equipment may require supplementary bonding, which involves connecting additional bonding conductors between different parts of the equipment. This can help to ensure that all metallic parts of the equipment are at the same electrical potential, which can reduce the risk of electrical shock. The NEC provides detailed requirements for bonding and grounding in a variety of different situations. It is important to consult the code carefully when designing an electrical system to ensure that all applicable requirements are met. In conclusion, the bonding of service equipment, including pad-mounted transformers, is a critical safety requirement that is outlined in NEC Article 250.104c. By properly bonding conduits and raceways to the equipment grounding conductor, terminal, or busbar within the transformer, a continuous electrical path for fault currents is established, protecting both equipment and personnel from electrical hazards. It is important to consult the NEC and local codes to ensure compliance and to prioritize safety in all electrical installations.